All right, this is Mr. Weyrich. I'm going to be going through independent and dependent events, the notes with you for just a bit here. Sometimes when we're talking about the probability of an event, if you do things around that, it can change the probability of an event. Now, some of these are going to be pretty obvious. Some of them are not going to be as obvious. Flipping a coin twice, it doesn't matter if it came up heads the one before. That doesn't make it more or less likely to come up heads. So that's going to be an independent event. If you flip a coin and then roll a die separate, the coin landing on heads doesn't change the probability of the die coming up like a 1, a 2, a 3, or something like that. Or if you pick a card out of a deck of cards and then you put it back and then you shuffle them and you pick another card at random, that doesn't change the probability of those. So if they don't affect each other, they're independent events. If they're dependent events, something has changed the probability. So I picked a card out of a deck, I didn't put it back, I grab another one. So your probability of being dealt a specific card is going to change if you are dealt, say, 5, 6, or 7. Then if you are pulling something out from a bag, typically they talk about marbles in these questions. You pull marbles out of a bag and you keep those ones in your hand and draw another one. Those are going to be dependent events. So let's take a look at the examples real quick. There's just a few of them. It's a pretty short set of notes. There are 4 nickels and 6 dimes in your pocket. You randomly pick a coin out of your pocket and then return it to your pocket. Then you randomly pick another coin. Both times the coin is a nickel. That should actually be independent, even though it's kind of silly. Nickels and dimes are not the same size. You can tell those apart. You flip a coin and then roll a fair 6-sided die. The coin lands heads up. The die shows a 4. Those are independent. The coin flip doesn't affect the dice roll. The dice roll doesn't affect the coin flip. And then there are 14 shirts in your closet, 6 blue and 8 green. You randomly select one to wear on Monday and then a different one to wear on Tuesday. These would be dependent because if you wear, it says a blue shirt on Monday, that cuts you down to 5 blue shirts left. So it gets less likely for you to pick a blue shirt and more likely for you to pick a green shirt. It's dependent because they kind of change each other. So if we look at this student data, view assignments, this independent versus dependent is scheduled to show up. If we take a look at the skills, when we're looking at this, a box of chocolates contains 6 milk chocolates and 4 dark chocolates. You randomly pick a chocolate and eat it, then you randomly pick another piece. Both pieces are milk chocolate. The fact that both of them are milk chocolate isn't anything about whether this is independent or dependent. The thing about it is you pick a chocolate and you eat it. So you have changed the probability of what you could possibly draw on the next one. So this instance here would be a dependent problem. So that's all this one is a bunch of questions like that. There are 20 questions that are going to be there. So you just kind of go through, you work those 20 problems, and they're all kind of, it's like true, false. So you should be good. Okay. If you have questions, of course, you can save those for when I come back. And good luck up to that point.